Well, hello everybody, and welcome again to another OpenShift Commons briefing. And this time, because we are on such an operator framework and OperatorHub.io kick this week, we thought we would do a talk on operators for Ansible people. There's a huge community of folks out there that we are really thrilled with all the work and all the playbooks and all the work everybody's been doing. And we wanted to make sure that we properly got their point of view incorporated in the operator stuff. And so this is a presentation by Michael Hrivnak with a few others that he'll introduce as well. They're going to answer all of your questions, hopefully, and get your feedback. So Michael, I'm going to let you introduce yourself and the others that are going to be in the call as well.
Thank you, Diane, and thank you all for joining. My name is Michael Hrivnak. I've been at Red Hat for almost 7 years now, based in the Raleigh, North Carolina global headquarters office. I've been working on a variety of container-related things since the very earliest days of Red Hat getting involved in the whole Docker ecosystem and shipping Docker containers, and then through the transition into Kubernetes. And most recently have been working on the Operator SDK, and in particular, focusing on the Ansible side of that. So today we're going to dive pretty deep into not just how operators work, but how to use Ansible to make an operator. So save up your questions, ask some questions in chat. We've got some other folks on this call, notably another engineer who's been really one of the leading engineers on the Operator SDK and the Ansible bits there. So he can answer your hardest questions too while I'm talking away. You can do those in chat. And then at the end, we'll try to save some time for questions then too. With that, let's dive right in. So what is Kubernetes? Obviously, we're not going to answer that question completely right now. Probably you already have an idea if you're on this call. But what I want to highlight about what Kubernetes is that it is a declarative system. Of course, it's broadly a system that can take some number of machines, whether they're physical or virtual, and turn those individual machines into a single cluster, a unified cluster that you can interact with and run your workloads on that cluster using this nifty little vehicle that we call container images. So Kubernetes being a declarative system and one that you interact with using YAML may be something that's a bit familiar to the Ansible folks on this call. So here's an example of how you would interact with Kubernetes to give you a sense of the experience of the API, and even not just API wise, but how as a human user of Kubernetes trying to run a workload in Kubernetes, this is the kind of thing that you have to create, either by hand or using some kind of templating engine or other tool. So on the left, we have a pod definition. A pod is the primitive for running a container in Kubernetes. And what I want to highlight here is the bottom half of that is the spec. That is your opportunity to specify what you want the state of the world to be. So here we're specifying that we want to run this container. We gave it a reference to an image. We told it to expose a port. And on the right side, we have this service primitive, which is the way of exposing a network service within a cluster. And again, we're declaring here a spec. We're specifying what we want the world to look like. We give this YAML to the Kubernetes API, and then we basically just walk away and trust that Kubernetes is going to make it so. Kubernetes will then, through the course of however much time it takes, do whatever is necessary to make these things reality. Now, as an Ansible user, you may be looking at this and thinking, well, that sounds a little bit familiar. Ansible, of course, is something you interact with by using YAML. And also the idempotent nature of Ansible. You want to, every time you run some Ansible code, you want to get the same result at the end, right? Regardless of what your starting point was. And Kubernetes is a very similar kind of concept and experience. Let's dive now into how to use Ansible to interact with Kubernetes, and which is really the foundation of before we get to operators. What we need to know, and what I think is really the most powerful part of all this, is just how easy it is to use Ansible to interact with Kubernetes, regardless of whether you're trying to do that to make an operator or do it from some other kind of tool. Okay, on the left, we have some Kubernetes YAML, similar to what we looked at just a moment ago. And this is the kind of thing that we could take that YAML on the left exactly as it is, write it out to a file, and use kubectl, kubecontrol, kubectl, whatever you prefer to call it, and say kubectl create -f and give it a path to that file, and it would read this YAML and then go create a resource based on this YAML. Well, instead of using that command line utility to do that, we can use Ansible and do this thing on the right. So on the right, we have an Ansible task. A task is the generally smallest amount of work that you want to tell Ansible to do. So you would classically have tasks in a collection that are in a file together, perhaps, that do things in some order, like you'd have a task to install some RPMs or Debian packages. Then you might have a task to enable a systemd unit file or something like that. And you can go on and on. Well, here's a task that just creates that resource, and it uses the K8s module to do it. As you can see, it's super easy, and it's exactly the same YAML here in red as I have on the left. Now, the one change I did make, just to kind of show off a little bit, is that we're templatizing the value here within that data block. So we're just using Ansible's inherent ability to do Jinja templating very seamlessly. But otherwise, you can take your existing Kubernetes YAML and just directly inline it to an Ansible task, and that's it. And now you can run this Ansible task, and it will create that resource for you. So just as a Kubernetes client, Ansible is super powerful. And what if you don't want to inline that YAML, but you want to just use your manifests from the disk where they already are, or you want to use templates there and templatize them as files, individual files? Well, you can do that too. And just with this 3-line task here, this is all it takes, you can use this foo.yaml file as your template and put as many resource definitions in there as you would care to, and templatize them however you like. And when you run Ansible, of course, when you run Ansible, you provide it some kind of input or some way to know the values of the variables that you're going to have in your template. That's all very easy if you're not familiar with Ansible. But in this case, those values get passed straight through very seamlessly into that template. The template gets rendered, and whatever's in that template gets created. So here again, Ansible is just a very convenient, very easy to use Kubernetes client. And this is an Ansible role. We can't really talk about using Ansible without talking about a role. Now, this is for Ansible people, this session right now, but I suspect there might be a few of you who aren't that familiar with Ansible anyway. So an Ansible role is a way of packaging up related Ansible code for reuse. So you might make a role that deploys a database. So you'd have your MySQL role, perhaps, and use that MySQL role to deploy a database on your infrastructure somehow. So you would put all these assets together that are related to that, and that is a role. There are different tools that will help you scaffold out this skeleton role here, so you never have to concoct this by hand. Ansible Galaxy is the most common one to use. So what we're going to focus on today is creating a role that knows how to deploy and manage a specific application in Kubernetes using that K8s module that we were just looking at. In Ansible Galaxy, I want to point out, is a central location on the internet that you can use to share roles with the world. So it's a little bit like the Python package index, for example, or Puppet Forge, or other similar things. And down here highlighted in yellow are the two things that you need to know about in order to successfully create a role for your application to deploy it in Kubernetes. The first one is, so remember, some tool is going to scaffold this out for you, and I'll show you one of those tools in a little bit. You're going to get this skeleton, and you're going to go into that templates directory and just drop whatever YAML files you want in there that are your Kubernetes manifests. Then you're going to go into that main.yaml file in the tasks directory, and that's where you define those tasks that we were looking at just a moment ago. And that's really it. That's all you have to do to use Ansible as a very powerful Kubernetes client. All right, so why use Ansible with Kubernetes? Let's tie this together at least. So we have similar patterns of writing declarative or idempotent YAML. It, I think, is a very similar mindset that you're in using one system or the other, so they go very well together. A lot of ops teams, of course, and even a lot of developers are already very familiar with Ansible. You may have existing investments in Ansible. You might be deploying things today using Ansible, but not in a containerized environment. So it can be a natural step to use or even reuse some of that existing Ansible investment in order to deploy those same things in a Kubernetes environment. And even if you're not already familiar with Ansible, it's very, very easy to learn and is a wonderful tool, I think very competitive with really any other tool out there that helps you to interact with Kubernetes. And it's very easy to learn. We've already covered this to some extent. And it uses familiar Jinja templating that's very familiar to many already. And is capable of full day 2 management. So right now, because this is a briefing, we have to try to keep this somewhat brief. We're just looking at the very basic way to interact with Kubernetes from Ansible. By creating resources, you can do similar things to remove those resources or update those resources, but it is very powerful. You can do all kinds of advanced things. So Ansible is a very complete way to interact with Kubernetes. Okay, this is what we've all been waiting for, operators. If you haven't heard enough about operators, we're going to talk some more about operators and specifically how to make one with Ansible right now. So first off, what is an operator, if you aren't already familiar? So an operator, to start, is a Kubernetes controller. So it is an application running in your Kubernetes cluster, and it is watching for events that happen inside the cluster, and it is responding to those events, and it is always looking at resources and what somebody has specified in those resources as their desired state of the world, and then excuse me, and then it is making changes to the world to bring the real world closer to what is specified in those resources. Now, an operator is a special kind of controller that is purpose-built to deploy and manage an application. So that application could be something like a wiki or a database or some microservice or some large service. Whatever kind of workloads you need to deploy into your Kubernetes cluster could be used in this pattern as the target that's being managed by an operator. And then lastly, what we really think about in terms of operators is human operational knowledge in code. So anything that a human administrator or systems engineer type person would need to do to maintain and keep an application or some workload running in a cluster indefinitely, we want to automate as much of that as we can. And in this case, we're automating that by using an operator. So not only is your operator going to understand how to deploy this application when it is told to do so, but it will know how to automatically do things like upgrades and do them safely, maybe even with rollbacks. It'll know how to scale this application, and maybe not even in the most basic way. So many of you have seen, for example, the classic OpenShift demo where there's a big plus button in the user interface, and you can just kind of hit that plus button a few times and see more pods appear. And so now you have more instances of your application running. Well, that's great. But sometimes you want to do scaling either in more intelligent kind of ways. So maybe you want to watch some very specific metrics, some kind of queue depth that might be multiple services upstream from your service, and proactively scale out your service based on that queue depth somewhere else. Or maybe you need to take specific steps that you can't just start up more containers, but you have to take actions in order to establish trust and maybe repartition something and introduce a new container into an existing collection of running containers. If there's anything advanced you need to do like that in terms of scaling, Operator's perfect for that. Backups, of course, often require some kind of multi-step process of quiescing a service or turning it to read-only or something like that. That whole workflow is a great fit for an operator. And then, of course, everybody's favorite, nobody wants to get paged in the middle of the night. So if you can automate common failure scenarios or even non-common ones, but ones that you could perhaps anticipate, your operator can automatically repair your application for you. So hopefully you'll never have to deal with that. And of course, that's how you really scale out your human operational knowledge, by automating it. And of course, since I know this is for Ansible people, I'm preaching to the choir. All right, so Kubernetes is a little bit unique in its API in that not only does it have the kind of REST-ish API that you can imagine. So there's a whole bunch of endpoints that represent the different resources like pods and services and secrets and config maps, all that stuff. But Kubernetes invites you and me to extend its own API and add your own endpoints into its API. And this idea of custom resources is what enables that. So here what we have is an example of a memcached resource. Of course, Kubernetes doesn't have a memcached resource. That's something that we just made up. And we made it up in order to represent the ability to deploy a memcached in the cluster. So once you've created a custom resource definition, now the Kubernetes API has all these extra endpoints that understand how to create and update and delete and do some other specific kind of things with that new resource type. So it's very easy to do, and this is central to the operator pattern. Whenever you're making an operator, we're using the Kubernetes API to interact with that operator, and we're doing so by creating a custom resource. So a few minutes ago, we were talking about we're going to create an Ansible role that knows how to deploy some specific application in Kubernetes. Well, the second phase of that, of making an Ansible-based operator, is going to be, now we have a role, let's make a custom resource in Kubernetes that represents that role and represents the input that role would take, and then the Ansible operator is going to tie those two things together. So now we're using the Kubernetes API to drive Ansible, which is pretty cool. Okay, and speaking of that, here's an illustration of how that fits together and how that works. So we have this this smiling little face on the top left of this screen, and that client is interacting with the Kubernetes API. And so imagine we have some custom resource, like let's say it was memcached. That client creates a memcached resource. I'm hearing somebody else's audio, so maybe if you're out there unmuted, it would help to mute yourself. So you're this smiling face, and you've got this API that you're interacting with, Kubernetes API, and you've created your resource. Now what? So we have this orange controller in the middle here in the bottom. So again, this controller is itself just another container running in your cluster. It's an application sitting there running like any else. But it's talking to the Kubernetes API and using this watch feature. So it's able to watch for events that happen that are related to a particular resource type. So in our case, our controller is watching for events related to this particular resource. And when it sees one of those events come in, all it does is it runs reconciliation. Most controllers, most operators end up having one large function called reconcile. And that reconcile function gets called every time one of these events happens. And that reconcile function does what you might expect. Its job is to look at the resource, look at the spec, and see what has been specified there, what is the desired state of the world, and then go look at the real state of the world and try to move it closer to that desired state. So here in our case, because we're talking about operator pattern, what that reconcile function is going to do is ensure that these pieces, the required pieces of your application, exist, that they're healthy, that they're talking to each other, and so on, and that they meet all of the parameters that you have specified in your custom resource. So how do we make one of these things? Well, we have the Operator SDK, and there's a good chance if you're on this call, you've heard of this thing before. So the Operator SDK helps you to not just create an operator of your own, but also it helps you with testing and especially with packaging so that you can make your operator available to others. We're going to look in detail at that in just a few minutes. Now, you can create an operator by using Go. That's a very natural way to do it. Or, of course, you can do it in Ansible. That's what we're looking at today. And you can create an operator using Helm. Helm-based operators are not quite, they don't have quite the potential as Go or Ansible in terms of day two management, like really advanced kind of patterns of doing that day two scaling and backup and repairing and all that sort of stuff. But Helm can be a very effective way to get an operator and get a functioning operator, make your application Kubernetes native, at least from a deployment standpoint, very quickly if you already have existing Helm charts. And of course, here's a link to where you can find the Operator SDK. Now, the Operator SDK itself is part of the Operator Framework. The Operator Framework includes the Operator SDK. It includes Operator Metering, which is a project to track resource consumption of an operator and generate reports on that, useful for all kinds of exciting things. And then the Operator Lifecycle Manager, which will be probably the most exciting thing to most people on this call. That is the thing that manages, it's kind of like an installer for operators themselves. So it manages what operators are available and running in your cluster right now. Last week's briefing, I just wanted to give a shout out to this, was called State of the Operators with Daniel Messer. There's a YouTube link here. Highly recommend you check that out. He gave a very nice overview of just the total picture of operators, the operator framework, gave a nice demo of the Operator Hub, which we're going to see again here for a bit of a repeat appearance in a few minutes. But if you're interested, just get a broad overview of what the current operator framework and operator landscape is. Highly recommend you go there. If you don't catch this link here, I found it pretty easy to find just on the OpenShift YouTube channel from about a week ago. So definitely check that out. Okay, so this is the pattern we were looking at just a minute ago. So just refresh, we've got our controller in the middle, we've got an application that popped out of it on the top right, and we've got this custom resource on the left. So what does this look like if we introduce Ansible into this pattern and implement this controller using Ansible? So here's what we have. In the middle, now we have this Ansible operator. So we have the Operator SDK box here inside the operator box. So basically what that is we have, as the Operator SDK team, already built an operator. We built that operator using Go, and it's a generic operator that will run Ansible for you based on how it's configured. So what you tell that Ansible-based operator is, for any given resource type, when you see an event for this resource type, I want you to run this Ansible playbook or role. So that's where this watch file in the very middle comes into play. We'll look at an example of that in, I think, the next slide, or a couple slides from now. It's a mapping between a resource type and a role or a playbook. And that's pretty much it in terms of what you need to provide, is just the actual Ansible code itself and then this mapping. And the Ansible operator itself does all the other operator type things. It takes care of all those nitty-gritty details for you. I will point out that if you've looked at what it's like to write an operator in Go, it's a very powerful way to write an operator, but there are quite a few advanced and complex concepts involved. This is, of course, both good and bad. I mean, it's all good stuff. There's some very advanced and powerful caching and queue management features that are built into Kubernetes Client Go. So we're very fortunate that all that is done for us, and they're available to use. But it does take quite a bit of knowledge and learning and just time to get some experience to get comfortable with that stuff. So if you don't have that time or don't want to take that time right now, especially to learn all those Go specific things and client Go specific things, the Ansible operator uses all of that itself, so you can take advantage of all of those things, but not have to worry so much about them and focus on writing your Ansible. Okay, so here's yet a deeper and more detailed picture of what that interaction looks like. So this smiling face interacts with the Kubernetes API still, and it creates this custom resource. Now, there's a second component of this resource that we haven't really talked much about yet, and that's called the status. So I'm looking at this bottom left gray scrolly box now to explain that. So the status is another section of a resource in Kubernetes, and it's where the controller or the operator can put some information about what its understanding of the world is right now, so that an end user like you or me, or some automated system, can look at that resource and get some idea of what's going on in the system. So if there were perhaps any error conditions with your associated with your application, those excuse me, those might get represented in the status section of your resource. Or let's say you've requested that there be 10 of something, like 10 copies of your process running, but only 7 of them are currently running. The status is somewhere that your operator might put that information and say, okay, there's actually 7 in the world right now that I know about. So that's how you know what's going on. The Ansible operator will write a generic status for you and put some reasonable things in there about what happened on the most recent run of Ansible. Many of you, if you're Ansible users, are familiar with the kind of information Ansible itself will show you as a summary at the end of its run. Things like how many things changed, or how many things had an error condition of some kind. That same data gets aggregated and represented onto the status of your resource automatically by the Ansible operator. Now, on the right side of this yellowish box here, we've got Ansible Runner, which appears here. Ansible Runner is a tool that came out of the AWX project, which is also known as Ansible Tower downstream. Ansible Runner is really a vehicle for running Ansible code in a programmatic way, in a way that is machine parsable and machine drivable. So we found that to be very, very useful and just the perfect fit for what we're doing here. Ansible Runner itself, as it's running the Ansible code for each task that happens and for other cases too, potentially, it sends events. It emits its own type of events over HTTP back to whoever's listening. And in this case, our operator is listening. So the Ansible operator already set up to receive these events, parse them, make some sense of them, and use that information to not just manage running Ansible Runner itself, but also to then represent what did Ansible do onto the status of your resource. Now, the last thing I want to look at on this slide is one of my favorites, honestly, is this proxy on the right. This proxy is a pretty neat thing that does some exciting things for you. So it is just a reverse proxy for the Kubernetes API. So when you run your Ansible code, well, when Ansible Runner runs your Ansible code, it does so in an environment that is configured to use this proxy for Kubernetes API access. So any standard Kubernetes client, whether you're shelling out with kubectl or using the Ansible Kubernetes module or something else, any standard Kubernetes client should automatically see this configuration and use it, and just automatically interact with this proxy when it's interacting with Kubernetes API. And there are 2 key things that this proxy does for you. Number 1 is it lets you take advantage of the cache that the Ansible operator itself is already using. Very important, by the way, in controllers, in Kubernetes, that an intelligent cache be used when interacting with the API. Your average, like standard Kubernetes cluster can have well over 100 different controllers running in it, maybe hundreds potentially, depending on what you're doing with it. If all of those are hammering away at the API server all the time, we really could just bring that thing down just from the like standard low level, almost idle state of these controllers. So having a good, solid, reliable caching system in place is important, and this proxy allows your Ansible code or anything else take advantage of the same cache that the Ansible operator is using. The second thing is that Kubernetes has this idea of garbage collection and resource ownership. So we can say that for these pieces of your applications, these little triangles and such in the top right, For each one of those pieces of your application, we can say that it is owned by that custom resource, that green custom resource on the left. What this gets you is that, say you create a memcached resource, and then your memcached operator goes off and creates a bunch of pods and service and maybe persistent volume claims and who knows what else, all these other resources. Each of them can be owned by that original memcached resource that you created. And the real advantage here is that when you later at some point go and delete your resource, the Kubernetes garbage collector will automatically then go and delete those other owned resources. So rather than make you, as a person writing the Ansible, figure out how to add those resource references yourself, those owner references yourself, and make you remember to do it for each one, we just do it for you. So this proxy automatically adds those resources to every resource that you create, and then it just becomes a seamless experience. So there's a lot here just built in and doing a lot for you under the hood. Okay, so we talked about that watches file. So let's look at an example of that watches file. This is a very basic example, and this is the kind of watches file you would be looking at when you first scaffold out your skeleton operator. Any given resource in Kubernetes, any resource type, is identified by a group, a version, and a kind. So here we're saying for this group, version, and kind, run this playbook. That's it. So it's a very simple concept. So this is something that you as the Ansible operator author will provide, but like I said, we have a tool that's going to scaffold this out for you and auto-generate this, auto-populate it for you. You could add more entries here, you could change the path of the playbook if you care to, but ultimately this is what ties together the resources in Kubernetes with some kind of Ansible code. Now, let's look at input and output as they pertain to the Kubernetes API and pass them through to Ansible. So on the left, I've sort of, we've taken apart an example custom resource and are just showing what each sort of section is for. And we've looked and talked a little bit about the spec already. So when you create a custom resource that an Ansible operator is watching, you can, in your spec, put any number of key value pairs. And when you do create those key value pairs, which I have as green here, the Ansible operator translates those for Ansible and injects them into Ansible as extra vars when it runs Ansible. So what that effectively means is the bottom line is these key value pairs you put into your resource on the left are seamlessly passed into Ansible and available for you to reference inside of a template. So the end-to-end is very easy. It's very intuitive, and you can just make your Ansible-based templates and then put the key values in your resource, and the operator in the middle takes care of all the details for you. And then the status we talked about already a little bit. The status is automatically generated by our operator. Now that said, what I should have pointed out earlier is that you have the option to put your own information in that status if you would like to. As a starting point, for most people, it makes sense to let the Ansible operator create its generic status and see how far that gets you, see how useful that is. And if you find that you have a need to put your own custom information into that status, you can do so. The Ansible operator provides some mechanisms to enable you to put your own information into that status. Okay, and what does an Ansible operator image look like? So on the bottom here, the green stuff is what we provide. The green stuff is the base Ansible operator image. Of course, it includes Ansible itself. It includes Ansible runner, and it includes the Ansible operator binary, which is that generic operator that we've already written for you. That's is itself written in Go, takes advantage of all the client Go features. What you add on top of that base image is pretty minimal. It's just that stuff in yellow here. So a watches.yaml file that we looked at a minute ago, and then one or more Ansible roles or playbooks potentially. And from that watches YAML file, you just tell it for this given resource, you need to create this Ansible role. That's really the only stuff you provide. Our tooling adds some other stuff in there for you, but in terms of your role, to overload that word in this whole thing, this is what you need to provide. And how do you provide that? Well, we talked about the Operator SDK before, but here's what it looks like in action. So if I was going to start a brand new operator right now and do it in Ansible, I could run this command: Operator SDK new, memcached operator, gives it a name. We tell it about the group version and kind for the resource that we're going to create. And then at the end of this command, we say -- type equals Ansible. And what does that do for us? Well, it creates a skeleton Ansible role for us. So we can already have that tasks file that we can go in and start adding things to. It creates that mapping file already populated, so it's already correct and ready to go. You don't even have to do anything to it by default. It already references this resource type, and it already references that role that got scaffolded out for you. It also creates the custom resource definition for you, which is another YAML file, another resource that you need to create in Kubernetes. So that all just gets created for you and is available for you to use. And then it creates the deployment manifest for your new operator and all the other related things to establish the right RBAC permissions for your operator when it's running, and to actually run your operator in a Kubernetes cluster. And then we have this hybrid use case that is developing. It's a little bit in the early phase right now, but it is available and you can use it. And actually, we'd really like some input from folks about how they would like to use this and what we can do to make it even more usable for you. But basically, the idea here is, say that you're creating an operator using Ansible, but at some point you just find that you need to write some logic in Go. Could be a lot of different reasons. Maybe you want to take advantage of a very specific feature in client Go or some other part of Kubernetes code. Maybe you want to use some other Kubernetes library. In my case, I had to do this recently because I needed to implement an interface. And actually, the way that I needed to create my operator was to implement an interface that this other sort of generic Kubernetes controller was going to use. So it's a Go interface, so you got to do that. The Operator SDK has this hybrid mode that enables you to still write Ansible code that gets run at reconcile time, but also gives you an opportunity to then have your own Go code and either modify the operator's behavior or just add to the operator's behavior. Okay, so next up, let's talk about OperatorHub. So back for a repeat appearance is none other than Daniel Messer himself, who was on last week. He is a senior product manager at Red Hat. He's really the guy to demo OperatorHub and its integration into OpenShift. So I think Daniel's on now. I'm going to unshare and turn it over for a couple minutes to Daniel to really show off here how that you can consume these operators.
Thanks, Michael. I suddenly feel very old being called out so senior. So let's do something fun and go to OperatorHub.io. I'm going to quickly share my screen here to get this introduced to you. So hopefully you've all seen, acknowledged as well, how easy it actually is now to write an operator, right? You don't need to be able to basically write an operator and Go. You don't need to be familiar with all the nitty-gritty details of how to connect to the Kube API and consume things like listeners and watches there. With the Operator SDK, you can basically just scaffold almost everything that's needed for that out, except obviously for your Ansible playbook, right? And as you all know, Ansible is fairly easy to get up to speed with, even if you aren't familiar with it yet. And using the quite mighty K8s module, you would be able to quickly orchestrate on Kubernetes using the Ansible operator. Now, let's say you've done that, the operator works, it's awesome, it has all this nice functionality. What do you do with it, right? You want to publish this somewhere. You want to push this out to the world and have people use it and test it. And as it happened to be, we actually released such a place last week on Thursday, aiming to be a central point where the Kubernetes community comes together and shares operators. And that's really what OperatorHub.io is about. So we have an operator hub in OpenShift, which is basically a curated set of community operators, Red Hat maintained operators, and certified operators from partners with commercial support that you can directly deploy in the cluster. But we've also stood up OperatorHub.io, aiming for the same experience, but for general Kubernetes clusters. So the operators that we start together here are not limited to OpenShift, OCP, or OKD, but should work basically on any Kubernetes cluster, right? So on the side, you have an index of all the operators that we have currently curated. So this is basically coming off a GitHub repository that you can find under the Operator Framework organization. It's called Community Operators. And essentially, all that you need to do in order to contribute there is simply create a pull request, right? The pull request will contain your operator. Primarily, it's metadata formatted in a certain way so it can be used and picked up by the Operator Lifecycle Manager. Michael hinted on that before. This is the component in the cluster that centrally governs all your operators. So that's how you install operators. That's how you do dependency resolution should your operator, for instance, require other operators. And it also sets up all the Kubernetes artifacts that are required to run an operator, like most prominently its own custom resource definitions, as well as a fair portion of role-based access control in order to enable the operator to work on your behalf. So the packaging for this is well documented, and we link to it directly on the OperatorHub.io page as well. You can basically click contribute and learn in the submit your operator page how you would package up your operator once you have created it using the SDK. The nice thing about the SDK is that it gives you a couple of shortcuts, right? So primarily to generate the metadata that is required to have the operator both displayed nicely on the embedded Operator Hub and OperatorHub.io, but also to be installed reproducibly by OLM, you need the metadata file, which we call cluster service version. So the CSV is something you can generate directly from the SDK if you have written your operator with the SDK, as you probably do when you're aiming to write an Ansible operator. When you have that, you basically orient yourself on the format of the operators that are in here. So you can, for instance, go to community operators, look at etcd as an example, and see there is always a package YAML, a couple of CRDs, and then one or more versions of the cluster service version metadata file. And in this file, you basically put in information that is showcased eventually on the hub when you click on such a detailed pane here, right? So every operator here has a description that describes the features it has, how to use it, and also which resources this operator introduces in your cluster, right? So the idea is to basically provide these custom resources as the single user-facing interface for the application that your operator manages, right? So as a developer, I don't want to deal with, an etcd cluster that's made out of, 12 pods, like 12 PVCs and free services. I want to look at this as a single cluster, right? And it's exactly what the usage of custom resource definitions here provides. So on OperatorHub.io, you can see the operator, which operator submits and owns which custom resource definition, and you can also see, for example, YAML code, how you would use that on the cluster. So you can see here, standing up an etcd cluster with the use of the etcd operator is almost exactly similar as standing up a deployment or a build config or a config map on OpenShift or Kubernetes, right? So it's a very native integration into Kubernetes look and feel, so to say. And Here in OperatorHub.io, we show you how to do this. We also give you some data about the operator itself. For instance, who's maintaining it, where to find documentation, what is source code, who would be a contact if you have suggestions for that. And we also allow maintainers and publishers of operators on OperatorHub.io to subsequently update the version of the operator that they have published here in order to have people always get the newest version, right? So if I select here, it's like going back in time. I can select an older operator version and see that, for instance, 061 didn't have the etcd backup and restore functionality in there as we have today. Another important thing that we denote here is the capability or maturity level of an operator. So we've introduced this notion to basically convey to users of operators what the operator can do and cover in terms of the overall lifespan of an application, right? So if you click here, you kind of get an overview of what this maturity model looks like, and you can see Ansible operators span the entire set. So using sophisticated playbooks, you could not only cover the basic installation, you could also handle orchestration between upgrades, primarily aimed at stateful applications, to extended lifecycle operations like backup, restore, failover, failback, and use components from the operator framework like operator metering to generate metrics and alerts from the application that your operator manages. If you want to completely make the application available as a managed service in an autopilot fashion, as we call it here, you would even then use the metrics and alerts gathered from the application to react dynamically on this. For instance, to do auto scaling or auto tuning or recovery from abnormal behavior, right? So this is the operator maturity model, and we use this to convey to users what kind of abilities they can expect from an operator. One nifty thing that we are also able to do, because we basically parse all the CSVs we have, all the cluster service version metadata files that we have in the community repo to render this page and give you all this data, we can actually give you a little bit of a shortcut to install this operator directly from the Operator Hub. So if you click on install here, even on a completely plain cube cluster that you got from Minikube, EKS, GKE, AKS, what have you, you can click install here, and you would get instructions on how to get started with this operator rather quickly on plain Kubernetes. In the prerequisites section, it tells you to deploy the Operator Lifecycle Manager because these operators are packaged in the cluster service version format and are essentially deployed and updated the same way as in OpenShift. In order to get started with OLM in a test setting, you would just copy and paste this command, run it, and this would instantiate all the resources that are needed to run OLM. And then, in order to install the operator itself, you run this command. So behind this endpoint here, we basically generate all the artifacts that are necessary to get OLM to install that operator for you. Depending on how the operator is written, you will get different behavior here. Some operators, like etcd, are written in a way that they expect to watch a certain namespace for its custom resource definitions. So let's say you deploy etcd in this namespace that we create for you here when you run this kubectl command. You would get the operator instantiated in that namespace, and once you start creating custom resources that this operator watches for, like etcd cluster or etcd backup, the operator would start to react on this. There are also operators that can do this on a cluster-wide fashion, so they can basically be installed in the namespace that you don't, as a user, normally have access to. So this would be something that an admin does. But still, since the operator watches for its custom resources in your namespace as well, you can still use it, right? Depending on whether or not the operator can do this, can be installed cluster-wide or can only be installed in a certain namespace, you would see operators that basically give you a different namespace here. So I may just pick an example. I think AWS is one of those, which can do that. So here it says the operator will be installed in the operator's namespace. That doesn't exist yet. Installing OLM will create this namespace for you, and then you will be able to use that operator with its CRs from all the namespaces. Okay, so check out OperatorHub.io. If you're interested in getting your operator up, by all means, definitely read through the submission and contribution guide. You can also get a little head start on how to use the SDK in general and what an operator is if you have never used that before here, with the appropriate pointers for more information. And then all you need to do is basically submit a pull request against this repository here, and we would then get in contact with you, ensure that the CSV is formatted correctly, that it installs correctly, and has a minimum amount of information attached to it, like a logo, description of the operator, a couple of links to show people where who's behind that, and then obviously, hopefully, many examples as well as example YAML for the custom resource definitions that your operator owns or watches. That's pretty much it.
Great. Thank you, Daniel, for that overview. This is, for me, one of the most exciting parts of this whole thing is it's very easy, as we've seen, to use Ansible to make an operator to begin with and give your application this Kubernetes native presence, and then get access to this whole ecosystem now, this whole set of tooling for managing what operators are in your cluster, and then being able to interact with those operators. So let's wrap things up here. We've got a couple more exciting things to show. If I can just find the right window to share. Okay. Here we go. Okay. So we got to look at the Operator Hub now. We have some advanced patterns available to talk about. However, seeing as this is an OpenShift briefing and not a long-windeding, we're not really going to be able to dig into these patterns. But you could find me some other time, and we'll look at a couple of other opportunities that you could maybe do that in a minute. But to at least enumerate them, we have this idea of finalizers that we support. Kubernetes finalizers are a way that you can run some code before an object gets deleted. The Ansible operator absolutely has great support for that and will enable you to run your own Ansible code before your resource gets deleted, in case you need to do some kind of custom cleanup things, or perhaps interact with off-cluster resources, which is another thing Ansible's great at interacting with before your resource gets deleted. Upgrade. Upgrades are pretty straightforward to manage in Ansible. Ansible is a very powerful tool. What I really want to highlight here, and I'll just preface this with I'm doing some hand waving here. Those of you who know Ansible know that this version expression here is going to certainly be more complicated than what I've actually written here. But this is the effect. You can in Ansible create these blocks and run them in certain conditions when an expression matches and evaluates the true. So you can say when the current version is less than something, do some stuff that'll get you to that version. And then backup and restore is another thing that we can do. There's an example that you can see in GitHub. It's pretty easy to find. We re-implemented the etcd operator in Ansible just as an exercise, not trying to replace the original, just to really prove out our patterns. And it shows some patterns for being able to drive a backup workflow. Okay, what next? Learn.openshift.com is just a wonderful tool. You can go to learn.openshift.com and get access immediately, totally for free, no registration required. We don't need your details or anything like that. Just go there. The bottom left here, building operators on OpenShift. You can click into there, pick an exercise. There's some Ansible related ones, there's Go ones, and it will give you your own OpenShift environment, a real running OpenShift environment that you can interact with, and it will guide you through some exercises to make an operator yourself. There's one that will introduce you to just working with the K8s Ansible module, for example. There's really good stuff there. definitely check it out. Totally free and a very nice learning tool. Okay, and just from the Ansible side itself, I want to introduce here briefly Carol Chen. She is a community architect for Red Hat, focused on not just Ansible, but ManageIQ and probably some other things too. But she's going to say a few things about the Ansible community side of all this.
All right, thank you so much, Michael. We're very, very excited about the operators framework. I actually remember when I first heard about it, it was from you, Michael, half a year ago in Raleigh, North Carolina, as we were walking to dinner after my Ansible training. So I'm really excited about how much has grown since then and what we were doing with it, and also how well Ansible is positioned to be part of this creation process, making it so easy to create operators with Ansible. So on the Ansible side, we'll definitely like to support this process as much as we can. And so, for example, if you have some idea of some Ansible roles that can potentially be an operator, we want to be able to enable that, make that happen. And since most of these are relatively new, we also need to hear from you, hear your input on what specifically we can do to assist you. Perhaps, for example, making an operators category in Ansible Galaxy, which Michael mentioned is the hub for finding Ansible roles. So for example, through there, you can have some references on other operators that have been created. As you build your own, you can have that as a reference. So besides the online learning tool that Michael just mentioned, learn.openshift.com, I'm also working with Diane, Daniel, and Michael to bring this type of talk or even workshop format to Ansible meetups. So if there's something you're interested in, please contact me. I need to add my contact information to the slides. So I think I see probably Michael will be doing that after this talk. So I want to mention that on the line, I think we have Chris Short, who is the product marketing manager for Ansible. According to his Twitter profile, he should be on vacation, but he's still here with us today.
Yes, I am.
Yes, hi, Chris. Great to have you.
Hello. Thank you very much.
Oh, yeah, sure. Great to have you. And in any case, Chris is a great resource and connection for Ansible operators as well. So we'll put our information there on the slide. So I think we are running short of time, so I'll pass this back to Michael and hope to hear from the Ansible community as well as people writing operators, how we can help. Thank you.
Awesome.
Thank you, Carol. I did a quick ninja edit to the slide here, and I just totally forgot to add your information here. So here it is. This is Carol. Carol's name and her email address. And thank you so much for all that support. Quick two things. Tomorrow at Scale in Pasadena, California, we'll be doing some operator training tomorrow afternoon. So myself and one other person, Matt Dorn, will be doing that. There will also be some other operator experts present at the conference. I'll be at the Red Hat booth a whole bunch. So if you're in the area, highly recommend this event in general. Plus, great chance to continue the operator discussion. And then immediately following that on Monday, we have an OpenShift Commons gathering in Santa Clara that Diane mentioned at the beginning of the call. So there's a link here for how you can find out about that, the details and how to join us for that. And we will be at that event as well, doing some operator training in addition to the other usual events.
All right. Thank you, Michael, for a great talk, and thanks, Daniel, for jumping in, and Carol as well. From my perspective, I'm waiting and patiently to hear about people's operators that they're building from Ansible as a basis. So if you have them, if you can let Carol or myself know, or reach out to Michael, whomever, and just let us know so we can get you on the Google group. If you have any questions, there's a Google group for the operator framework, and there is in Kubernetes land, there's a Kubernetes operator Slack channel as well. So we'll post this video in the next day or so, along with a whole list of resources. And it is the end of the hour. there are a few questions that have been answered in the chat. I will try and endeavor to get those in a sort of FAQ section in the blog post and cleaned up a little bit. But I think what this tells me is that there's a lot of information here. So if you have any questions, please, ask them on, reach out to the GitHub issues list. There's documentation there as well. And there's a lot of documentation on operatorhub.io on how to get a hold of us. And hopefully we'll see you in Pasadena or Santa Clara or Boston at Red Hat Summit, or let's see, the next one after that is Barcelona and KubeCon. So there's lots of opportunities to meet up with us, as well as a monthly operator framework SIG on the third Friday of every month. So all of those resource links will be in the blog on blog.openshift.com shortly. And this video will be up on YouTube within the next 24 hours. So thanks again, everybody.